Welcome to Web Handling. My name is Dave Roysum. The framework is the skeleton that holds our machine parts together. There is perhaps no more important function than to hold the bearings of our rollers solidly in place. This includes resisting static deflection, as well as resisting dynamic vibration, as well as providing long-term stability. We also need to consider alignability and serviceability. Entire textbooks have been written on bearing applications, best practices, and sizing. We can do little here, but list some of the more important choices. Our first choice is how to mount the bearing, and that will largely reflect the choice of framework type and subtype that was discussed in the last clip. Our second choice is what basic style of bearings are we going to use. This largely depends on loads and misalignments. By loads, we mean radial and thrust. Many people do not know that rollers and nip can see upwards of mu times n force, where mu is the coefficient of friction between rollers and n is the nip force. This is caused because non-cylindricity of either roller causes the system to act like a cone drive. Perhaps surprisingly, maximum loads do not depend on the size of the cylindricity error, only on its shape. Pure tapers can reach near mu n, while very narrow and random diameter errors will cause little thrusting. By loads, we mean both static and dynamic. Static loading is weight. It also includes setting rollers on the floor or frame that can brunel the inner race due to impact. Dynamic loads include rotating weight plus vibration loads. Lubrication is another topic that Beloit, for example, had an entire engineering group devoted to. To make a very long topic short, you get what you pay for. Grease requires us to derate the bearing because grease traps contaminants, heat, and moisture. Grease also increases bearing drag, and that can be a problem with lightweight webs. Oil is better in those regards, and circulating oil with a filter and heater even better yet. We won't detail seals and shields here, other than to note that they should keep lubricant in and the outside world out. However, they increase drag, and that can be a real drag, excuse the pun, for rollers that run lightweight webs. Finally, thermal expansion must be considered for all but the narrowest of rollers, otherwise you will drive the bearing into thrust overload with even modest temperature changes. Some cheap idler rollers have free bearing mounting styles. Process rollers, on the other hand, are usually fixed on the back side and free on the front. Also, make sure that your maintenance people assemble the bearing in the correct part of the travel within the housing. If the roller will be running in a hot process area, the cold assembly will be with the free bearing near the inner limit of its range. Also note that thermal expansion makes bearing fits and clearances extremely challenging. Returning to our framework discussion, our primary choice of bearing mount is either on the face or on its feet. Face mounts are usually called flange mounts. The most popular foot mount is a pillow block. The bearings shown here are likely greased, sealed, and possibly self-aligning. Self-aligning is a bit of a misnomer, as it really means accommodating misalignment. Many rollers may need alignment and periodic realignment. While in principle any roller can be aligned, in practice some mounting styles are far easier than others. For example, the shear ledge shown here is as easy as it gets, while most bolt-bound dual plate designs are next to impossible to align. The shear ledge allows the crew to level first by shimming. Then they can square the roller as a second step without losing level because the ledge supports it. You can even go one step further for process rollers that may need frequent replacement. That is, to match machine the bearing housings so that the roller might not need to be realigned every time you change it. A final point of consideration is whether to dowel the bearing housings after alignment. Doweling prevents movement that mere bolt tightness might not. However, it also takes time, cuts up the bearing housings, and may not be needed except for heavy equipment. If you do dowel, however, there is no doubt on the procedure. You will drill, then ream, then drive the tapered dowel pins just after alignment, but prior to starting the machine. One or two realignments can take place by re-reaming the holes to the next bigger taper pin size. After that, you need to make new holes. Thank you so very much for watching this module in my Plant Practical video series. Stay tuned as we move on to more advanced web handling topics. Let me know if there's something that you would especially want to hear about. Be sure to like and share. See you next time.